Hi, Siddharth. Good morning.
Good morning, sir.
Again. Hmm. Doesn't look like anybody else is here. That's right. It's been anyway. I was in school.
So your voice is split.
Oh, hello.
Yes, sir.
I'm audible. Even your
Sir,
voice is
you're
breaking.
audible, but it's breaking up.
Yeah. Later over the voice now.
What, sir?
Over the voice is some really some interference kind of noise.
Sir, sir, I will rejoin the meeting, sir. I think there's a problem from my side.
Yes, sir, you're audible.
Okay, is there any disturbance here in the line?
Yes, sir, your voice is breaking a bit.
Okay, I'll just restart the system and I'll come back. Okay, just give me 2 minutes. Right? Okay, I'll just be back.
Okay,
Yeah. Guys, am I audible?
Yes, sir.
Is that disturbance still coming through?
Yes, sir.
Still coming through.
Yes, sir. Still breaking.
Can you see the screen? Is the voice breaking very badly? Hello? Is it like audible at least?
Yes, sir, but your
Please,
voice
I
is
can't
breaking,
hear
sir.
you guys properly.
Yes, you're audible, sir, but your voice is breaking quite badly.
Oh, okay. Mm. Just restarted the system, hoping it'll get better. That also didn't work. We don't know. Once again. Means. You guys know me properly.
So still, it's the same, sir. Maybe it's like a network issue or something. Not sure.
One second. Hello, can you hear me now? Is there any chance?
Yes, sir, it's better, sir.
Oh, it's better.
It's still breaking. Even your voice is breaking this side also. Yeah. Like that's how I know that okay,
Oh,
there's a
sir,
problem.
now it's a little bit better, sir.
A little bit better. Okay, that is good news. One second, I'll just check background how many apps are running. Anybody good at solving these problems? Please give inputs. I'm still wondering what to do. Hmm. It's lagging for me.
Could it be something to do with your internet, sir? Maybe.
No, that's the thing, right? Like I just checked speed test, I do speed test again one thing. So speed test is showing me good 40 Mbps. So I think it's something to do with the laptop. So I'll do a workaround. We'll do a phone class. We'll do a class to the phone. Okay. One second. Come on.
Yeah. Now can you hear me?
Yes, sir.
Yes, sir.
So what I'm doing is audio is on the phone and video is here. Is the video clear? Next question.
Yes, sir.
Yes, sir.
Yay. Okay, let's get started. All right. Oh, my laptop is hanging. Okay, we'll manage with what we have. Let's see. So, inverse trigonometric functions. All right. Am I audible first? Properly?
Yes, sir.
Yes, sir.
Yes, sir.
All right. Second. All right. So let's begin the class anyway. Sin theta has a principal value. What is the principal value? Like for the domain?
Minus pi by 2 to pi by 2.
Minus pi by 2 to pi by 2, correct. Minus pi by 2 to pi by 2. Okay, both close bracket. Now, what about cosec theta? Cosec inverse x equal to theta means cosec theta is equal to x. Now, what is the principal value for this?
Minus pi by 2 to pi by 2 minus 0.
Correct. Nice. Minus pi by 2 to pi by 2. That's where sin theta becomes minus 1 to 1. Okay. Now, in that, cosec theta is basically 1 by sin theta. So you have to make sure sin theta does not become 0. That happens at 0, and that point we remove. All right. Next is tan inverse x equal to theta. Matlab tan theta is equal to x. And this one's, what will it be?
Open interval minus pi by 2 to pi by 2.
Open interval minus pi by 2 to pi by 2. Tan of pi by 2, tan of minus pi by 2, undefined. Okay. Now, cos inverse x equal to theta means cos theta equal to x. So what is the principal domain for this?
0 to pi.
0 to pi. Good. Okay. Now, sec inverse theta. Sec inverse x equal to theta for this. So when I say sec inverse theta, I'm asking you for the range. Okay. Sec inverse x equal to theta. I'm asking for the range. What will that be?
0 to pi minus pi by 2.
Minus pi by 2. Good. Okay, there is still a lag. Okay. Then we have cot inverse x. Here it will be 0 to pi. All right. Any doubts here, guys?
No, sir.
Principal values of these functions like sine, cos, tan, all of it. Okay. So whenever I say sine theta equal to theta, theta will lie between close bracket minus pi by 2, pi by 2. When I say tan inverse x equal to theta, theta will lie between minus pi by 2 to pi by 2 and so on. Got this? So tan inverse x can never return a value of pi by 2. Understand that. Alright, that's the idea here. Alright. So let's begin with some questions. Tell me the value.
Seven pi by 12.
7 pi by 12. Pi by 12 is 15. 7 pi by 12 will be 105. That's correct. That's correct. Sine inverse root 3 by 2 will be 60 degree or pi by 3. This will be pi by 4. And when you add together, yeah, you get 7 pi by 12. Yeah. Absolutely right. Now, tan of cos inverse x equal to, in terms of x. Come on.
Sir, tan theta.
What is theta in this context? There's no theta given, right? So where did you use theta? So guys, it would be convenient for me to convert cos inverse x to tan inverse something. Because tan of tan inverse will come out as that value itself. Okay, that's the idea here. So how do you convert cos inverse to tan inverse?
So this is root of 1 minus x square.
Root of 1 minus x square by
by x.
All right. So we construct a triangle where cos theta is x. Okay, in the sense that let's call this angle theta. Okay. So cos theta is x means adjacent side by hypotenuse. Okay, so what does the third side become?
Root of 1 minus x square.
Okay, so this is how you convert from sine inverse to cos inverse and all of that. All right, between the trigonometric functions, this is how you convert. You would construct a triangle. All right, so tan theta will be what? If cos theta is x, what is tan theta? Root of 1 minus x square by x. So this, if this was called theta, then tan inverse will be root of 1 minus x square by x. So this question becomes tan of tan inverse, this value. Okay, got this?
Yes, sir.
Is my voice still breaking badly?
No, sir, it's clear.
No? Okay. Okay, so this answer becomes root 1 minus x square divided by x. All right. If you have any doubts, please stop me and ask. I'm just looking for the next question to continue. Okay, so before attempting this question, tell me this. Okay, so let sine inverse x be equal to theta. What is sine inverse of minus x?
Minus sine inverse x.
Correct. It's minus of theta. Correct. Absolutely. Now, if cos inverse x equal to theta, what is cos inverse minus x?
Pi minus cos inverse x.
Correct. Pi minus theta in that case. Correct. So, if tan inverse minus x, what will that be equal to?
Minus tan inverse x.
Okay. Cot inverse minus x?
Pi minus cot inverse x.
Okay, guys, did you all know this before?
Yes, sir.
Like sine based functions, like sine, cot, cosec. If you do, let's call that t. So you say t inverse minus x will be minus of t inverse x for sine based functions like sine, tan, cosec. For the other ones, cos based functions will be pi minus like trigonometric function inverse in terms of x. Okay, got this?
Yes, sir.
Okay. Now try to do this problem. I've taught you very minimal right now, but I hope that's enough. for you to solve the problem. Okay, first tell me, what is tan inverse 1?
Pi by 4.
Okay, good. So minus cos inverse minus half. I will write that as pi minus cos inverse half. Okay. Next, sine inverse half will be
Pi by
is
6.
there because I saw cos inverse half right next to it. So pi by 4 minus pi plus cos inverse half plus sine inverse half. All right. So when you have cos inverse x plus sine inverse x, what do you say?
Pi by 2.
That is exactly pi by 2. Okay. Guys, anybody who didn't know this? I hope not. Please tell me if you didn't know this. I'll explain. So you get minus pi by 2 as the value of x. Now, y is cos of
Sir, it's minus pi by 4.
oh yeah, minus pi by 4. Yes, it is. That's what I meant. Yeah. Cos inverse. Sorry. This is cos of half cos inverse 1 by 8. Right. So you need to find the relation between x and y or tan x and y. Okay. So you know x is minus pi by 4 and tan x will be minus 1 here. We'll keep that aside. All right. Look at y option. Cos of half cos inverse 1 by 8. Okay. So what do you do here? I will call this angle theta. Theta equal to cos inverse 1 by 8. In other words, cos theta equal to 1 by 8. Guys, this is nothing but trigonometry. All right. Learn to reverse the angle and the value. That's where the key is for this chapter. So what do you do here? This y becomes cos of theta by 2. Okay. Right. Since this entire quantity, cos inverse 1 by 8, I call it theta. This y becomes cos theta by 2. Any doubts here?
No, sir.
Okay. Then what happens next? How do you write cos theta by 2 in terms of cos theta? Root of, look, cos inverse 1 by 8 is an angle between 0 and pi by 2. It's in the first quadrant. If it was cos inverse minus 1 by 8, it would be in the second quadrant, pi by 2 to pi. Okay. So this is half of the first quadrant angle. So you know cos of a first quadrant angle will come out to be positive. So cos theta by 2, that is another representation of the same thing, will give you a positive value for sure. Okay. So remember this. This is 1 plus cos theta, the whole thing by 2. Do you know where this came from?
Sir, cos 2 theta.
Correct,
For-
correct. Cos 2 theta formula only this is. All right. So then this becomes root of 1 plus 1 by 8, which is 9 by 8, into 2, 9 by 16. This comes out to be 3 by 4. All right. So why is 3 by 4? Okay. So tan x is minus 1. So this is minus 4 by 3 into 3 by 4. Option C checks out. Are you following?
Yes, sir.
Yes, sir.
Yeah. So your answer will be option C here. All right. Sin inverse x plus sin inverse y is 2 pi by 3. What is cos inverse x plus cos inverse y?
Pi by 3.
Okay. Correct. So what is cos inverse x? So what is sin inverse x? Pi by 2 minus cos inverse x. Again, sin inverse y will become pi by 2 minus sin inverse x. This is equal to 2 pi by 3 or 120 degrees. So sin inverse x, sorry, cos inverse y this is. So cos inverse x plus cos inverse y equals pi minus 2 pi by 3. Okay, so what is pi minus 2 pi by 3? It's pi by 3 now. All right. Yeah, I hope you guys got this. Let's move ahead to the next one. given that x is less than 0, you have to find tan inverse x plus tan inverse 1 by x. Go for it.
Sir, is it pi by 2?
No, it's not. It's not. Did you write tan inverse 1 by x as cot inverse x? How did you get the answer?
Sir, I did I did tan inverse A plus tan inverse B.
So what did you get there?
Pi by 2, sir.
No. How did you get tan inverse A plus tan inverse B here? What do you do? It
Tan
becomes
inverse x plus 1 by x by
1
1
minus.
minus x into 1 by x.
Okay. So here denominator becomes 0.
Yes, sir.
Okay. So that time you can't apply this. All right. So, or what you can do is you can apply this. You have to notice the sign of x plus 1 by x. You know x is less than 0. Okay. So x plus 1 by x will also be less than 0.
Yes, sir.
All right. So this comes out to minus pi by 2 hence. But this is not the right way of doing it. This is not, by no means, this is the right way of doing it. There are conditions for which this formula applies. It does not likely come. So in exam hall, when you get the question, right, I don't want you to sit and solve. Put x equal to minus 1. X is less than 1. X then less than 0 is given. Okay, so put x equal to minus 1. All right. You get minus pi by 4 plus minus pi by 4 equal to minus pi by 2. That'll be your answer. But technically, how do we get to the right answer? All right. So this is tan inverse x. Okay, which is a negative value. Now, plus tan inverse 1 by x. If I call this 1 by x as some tan theta. Okay, so tan theta is 1 by x and x is negative value. That's the wrong approach. This is not what I meant. Okay, come on. Second is, what is happening here? Okay, finally. Okay, so tan inverse 1 by x. You know x is negative. Now, you also know that tan inverse 1 by x is equal to cot inverse x. Is this clear?
Yes, sir.
It should not be clear. It should not be clear. All right. Because this is valid only when x is positive. You know that tan inverse x or tan inverse of anything returns an angle. Okay. Either in the fourth quadrant or in the first quadrant. And cot inverse x returns an angle either in the first quadrant or the second quadrant, 0 to pi. Okay. This other one was minus pi by 2 to plus pi by 2. Are you following this much?
Sir, but this does make sense, right, sir? The 1 by x.
It makes sense only when x is positive. Look, like if I say tan inverse minus 1, for example, can I say that is equal to cot inverse minus 1?
No, sir.
Tan inverse minus 1 is minus pi by 4. Cot inverse minus 1 is 3 pi by 4. So when you get negative values for x, that's when this problem arises. Okay. So remember this, tan inverse 1 by x is cot inverse x when x is greater than 0. And it is pi minus cot inverse x when x is less than 0. Following now?
Yes, sir.
Yes, sir.
Okay. Not pi minus cot inverse. You get cot inverse x minus pi, right? Yeah, you get cot inverse x minus pi. Because cot inverse x can go up till pi. And once you subtract pi from it, you'll get a negative angle. And that is what you want here. Right? So it's cot inverse x minus pi here. Okay, this pi and this minus was wrong there. Got this, guys?
Yes, sir.
All right. So this becomes cot inverse x minus pi. All right. There's something wrong here. Oh yeah, there's something wrong here. Tan inverse x plus cot inverse x is always pi by 2. Is always pi by 2. Whether it's positive or negative, it doesn't matter. Okay. Because that's why cot inverse is in the second quadrant when it's negative, and tan inverse is in the fourth quadrant when it is negative. All right. When you subtract both, you will get pi by 2. All right. So here you get pi by 2 minus pi, which is minus pi by 2. Got this, guys?
Yes, sir.
Just look for other questions. Okay. Now we'll be learning some important properties. Forget questions for now. This is called T inverse T theta. Okay. Sin inverse sin theta is equal to theta for all theta between minus pi by 2 to pi by 2. Then what about cos inverse cos theta? Guys, note these properties down, okay? For all theta between 0 and pi. So tan inverse, T inverse T theta is equal to theta. Okay, for what all values. Otherwise, it changes. That's the idea. Right. So now, tan inverse tan theta is equal to theta for all theta between
open bracket minus pi by 2.
yes, open interval minus pi by 2 to pi by 2. Okay, what about cot inverse cot theta?
Open interval 0 to pi.
Open interval 0 to pi. Good, good, good. Now, cosec inverse cosec theta.
Minus pi by 2 to pi by 2 minus 0.
Minus pi by 2 to pi by 2 minus 0. Here, sec inverse sec theta 0 to pi minus pi by 2. Are you following?
Yes, sir.
Yes, sir.
Okay, so just remember this. All right. So let's try to draw the graph of the first part, sine inverse sine theta. Okay. So you can see that sine inverse sine x is equal to x. That's the idea here. From x between minus pi by 2 to pi by 2. Here, between minus pi by 2 to pi by 2 will be between pi by 2 and minus pi by 2. We have sine inverse sine x on our y-axis and x on our x-axis. Got this? Now, sine inverse of anything will not be greater than pi by 2. It will not be less than minus pi by 2 either. Okay. It will remain here itself. Now, between minus pi by 2 and pi by 2, it will be the value y equal to x line. Are you following? This is nothing but the value of y on the y-axis. So it's y equal to x between minus pi by 2 and pi by 2. Are you getting this much?
Yes, sir.
Okay.
Yes, sir.
Now, if I put a second quadrant angle, like say 3 pi by 4, what will the value of this be? If I put x equal to 3 pi by 4 here, if I put 3 pi by 4, will I get 3 pi by 4 outside here?
No, sir.
No, because x is not between minus pi by 2 and pi by 2. Okay, so sine inverse sine 3 pi by 4 is what? Okay, what is sine 3 pi by 4?
To do pi minus pi by 4.
Yeah, 1 by root 2. Okay, it's 1 by root 2. So sine inverse 1 by root 2 is what? Is pi by 4. All right. So this will be where pi by 4 is. This is where 3 pi by 4 is. So now if we take another angle, like a theta where it is between pi by 2 and pi, what will I get here? So you have to understand that when I put a second quadrant angle, if I get a value here, it'll return me this value here. Okay, it won't go beyond pi by 2. Okay, it will keep the graph between pi by 2 and minus pi by 2. This is how it goes. Okay, guys. So this is why this graph is so important. It shows you how you bring in all the sine inverse values between minus pi by 2 and pi by 2. Whatever value of theta you put. Okay, getting this? It's easy. Just mark the zigzag points. Mark the points where sine theta is 0. And you're good to go. You can start solving anything. Okay, so this becomes minus pi. This is minus 2 pi. Okay, so how do you find these different lines here? This is y equal to x line. What about this one? So this is y equal to x line. How do you find this line? You are moving it. It's the same line. You're moving it ahead by 2 pi units. What do you do for that? Y equal to x minus 2 pi. Guys, are you following? Guys, transformation of graphs. I taught you in the previous classes. All right. You change x with x minus a. You are moving it a units forward. You change x with x plus a. You're moving that a units backwards. Okay. So that's why this line here becomes x minus 2 pi. What about this line here? Can you tell me?
X
What about
minus
this
4
line
pi.
here? Exactly. It's x minus 4 pi. Are you guys following this?
Yes, sir.
Okay. Now look at these lines here. So you know this point will be pi by 2, pi by 2. And this point will be, what is between pi and 2 pi?
3 pi
3 pi by 2. And the y value will be minus pi by 2. Okay. So my equation, this slope will be minus 1. Okay, it's clear here. Y is equal to minus x. And then some constant is there. Okay, minus x plus e. Basically, if I draw y equal to minus x here and move it ahead by pi units, I'll have that value. Or you have 2 points here, you can find the equation of the line directly. It's your choice, whatever you prefer. However, you're used to coordinate geometry, use it. All right. So if I plug in the values pi by 2 here, I'll get c equal to pi. Or with these two, I can find these 2 points, I can find the equation of the line, which will come out to y equal to minus x plus pi again. Okay. So this is equal to y equal to minus x plus pi. What will this line be? So basically it changed y equal to minus x pi units ahead. So I change this to x minus pi. All right, inside the minus sign, inside the bracket. Okay, so then it becomes minus x plus pi. Okay. So similarly, what is this line? I equal to minus of x minus 3 pi. I move it 3 pi units ahead. Y equal to minus x line is here. And then I move this line 3 pi units ahead. So we get 3 pi minus x. Guys, this graph is pretty important. And it's very good for inverse trigonometric functions. Learn all of those graphs. Similarly, all right. So cos x will have a graph. Hey guys, did you understand this graph? Sine inverse sine theta graph?
Yes, sir.
Any doubts here?
No, sir.
Okay. So just remember, cosec inverse cosec x graph will not be defined at the points where sin x becomes 0. Okay, so these points will be removed. Other than that, it's the same graph. Okay, cosec inverse cosec x graph, only at those points they'll be removed. Are you getting this? It's the same graph only. Note that down as well. Okay, those points in the middle will be removed. It's the same graph. All right. Like that's why this topic is actually very interesting. It's all about how you break those big angles down to an angle between -π/2 and π/2 for sine base functions. Okay. Can you please try cos inverse cos? You know that cos inverse cos x is equal to x for any x between 0 and pi. Guys, what will the graph be like?
Sir, be forward the 0 points will be on pi/2.
I'm sorry, you're not audible. Hello? One second.
Cos graph and sine graph.
Yeah. What did you ask? What did you ask? Come again?
So the graph I said will be shifted forward by pi/2 units, similarly to the sine and cos graph.
Pi/2 units. Which direction?
Forward.
Oh, okay. Along the x-axis.
Yeah, yes, sir.
No. You have to understand that this graph, it's a weird graph. All right. So it's saying that between 0 and pi, okay, this graph has to be y equal to x. Got that? Okay. So between 0 and pi, it will be y equal to x line only. Everywhere else, what happens? And you should also understand that cos inverse can return a value only from 0 to pi. So this part and all will be ignored. They will all be folded down and up. That's the idea, between 0 to pi. That was the idea of these graphs. Okay. You will only get values between 0 and 1. And you can see live how it happens. And with the graph, whatever value of x they give, you can find like what is the line on which it stays, and you have the formula for the line. Okay, from which you can easily say this is the value of x whenever cos inverse cos x is given. Did you follow?
Sir.
Okay, so this it should have continued to be x, but then you can't get a value greater than pi. So that will be folded down here. Think like that. Okay, so this is pi. This will be 2 pi. And here it goes till 3 pi. And you go till 4 pi. And so on. Okay. So you can see the difference between that graph and this graph, right?
Yes, sir.
All right, that y equal to x line, till where is it involved? That's the idea. Okay, the rest it will be just folded into that zone between 0 to pi in this case, minus pi by 2 to pi by 2 in the previous case. Following? It is a little weird talking to the phone and the camera at the same time. Yeah. You guys, any doubts here?
No, sir.
This is the y equal to x line. Let's find the lines. What is this line? What is this line? This line, this line. I'll just mark it out using a different color. What about this line? This is y equal to? Just look at the line and tell me what it is.
X minus pi.
Look. This point is, what is this point? Minus pi, minus 2 pi. Okay. This is minus pi, comma, pi. It starts here and ends at 0, comma 0. What will this line be? This is nothing but minus x line. Okay, y equal to minus x is this line. This is y equal to x line, this one in front. Okay. Are you following? My cursor is not visible, huh?
No, sir.
Oh, okay. Like, till now I've been wondering, I've been thinking my cursor has been visible and that's how I've been explaining, like, till today, like from the beginning. Okay. Is there any option, where I can make the cursor visible?
Don't know, sir.
Okay, I'll just mark it out with a color pencil. Okay. So this is y equal to x line. All right. This is y equal to minus x line. Okay. And what is this line here? And I'm marking out till 2 pi. What is this line? You take minus x line and then bring it ahead 2 pi units. Got that? So what will that line be? Minus x minus 2 pi. Okay, that was y equal to minus x line. This will become y equal to minus of x minus 2 pi, which will make it 2 pi minus x. And that's this line. This line is 2 pi minus x, y equal to 2 pi minus x. What about this line?
3 pi minus.
No, here the slope is plus 1. Okay.
X minus 3 pi.
Are you sure?
No,
So
sir.
look at the point here. This is 3 pi, comma pi is this point, and 2 pi, comma 0 is the other point. All right. How do you find the line here? Y equal to mx plus c. What's the slope? y2 minus y1 by x2 minus x1. Slope is 1 plus c. So I put y equal to 0 and x equal to 2 pi into this. Y equal to 0, x equal to 2 pi. So the c has to be minus 2 pi. All right. So this becomes x minus 2 pi line. All right. This is nothing but x minus 2 pi. Or think of it like this. This looks like a modulus function, right? This orange part I've drawn out here.
Yes, sir.
Nothing but mod of x minus 2 pi. Before this, it's 2 pi minus x. After this, it's x minus 2 pi. That's it. Got this? So this is also one way of thinking. Any doubts here?
No, sir.
Did you understand how to find the lines here separately?
Yes, sir.
Okay. So suppose I give you a question. Cos inverse cos of 8 pi, not 8 pi, 8 pi by 3. What do you do? You will go to this graph quickly to find this first. Where does 8 pi by 3 lie?
Between 2 pi and 3 pi.
Exactly. All right. So you're looking at x minus 2 pi line. Okay. So here you write x, which is 8 pi by 3, minus 2 pi. Okay. That's how you use this information you have. All right. And 2 pi is nothing but 6 pi by 3. So the whole thing becomes 2 pi by 3. And 2 pi by 3 is between 0 and pi. That's the only thing you need to check in the end. All right. Are you guys getting this?
Yes.
Okay. So this is why this is so useful. And now, if I'm drawing sec inverse sec theta equal to theta graph, what will the difference be between cos inverse cos theta equal to theta?
Pi by 2 is not included.
Middle points at pi by 2 will be removed. Okay. Now, guys, try drawing tan inverse tan theta equal to theta graph. You already know that between minus pi by 2 and plus pi by 2, we'll get y equal to x line. Right? So you'll get values between minus pi by 2 and plus pi by 2 log. Okay. So from here, to draw it through till here, through the origin. Okay. Now, once you cross pi by 2, okay, once you cross pi by 2, you are in which quadrant? You are in the second quadrant. So this will be pi, this will be 3 pi by 2. So at pi it becomes 0, we know that. Tan pi is 0. Now, what happens here beyond pi by 2 second quadrant? Will it be folded? No. This, like pi by 2, it won't be defined. Okay, remember that. At minus pi by 2, it will not be defined. So you remove those points. And then, remember it's a periodic function, so it starts again from here. Okay. Here the period is pi. There the period was 2 pi. Okay, notice. In cos inverse cos x, sin inverse sin x, the period was 2 pi always. This is the smallest repeating unit. All right. So that's why it folded in and then it started repeating. Okay, think like that. And these are heuristics for you to just think. Just think in these terms. Okay. You have this, which is of a length 2 pi, and that keeps repeating for sine and cos, sec and cosec. Right. For tan, it's a little different. You already know that it will be pi equal to x line between minus pi by 2 and pi. But minus pi by 2 and pi will have a length of pi in between. Okay. And pi is the period of tan function and cot function. And that is the same thing that will keep repeating after that. Understood? Okay, so from minus pi by 2 to minus 3 pi by 2, it will be the same line with minus pi giving 0 value. But minus pi by 2 and minus 3 pi by 2 alone, those points will not be included. Any doubts here, guys?
No, sir.
Okay. Guys, with this outlook, I want you guys to go practice problems back home. Okay. Do you have problems to practice, or do you need me to give you problems?
We have it, sir.
You have?
We have it, sir. It's there in this year's book and some extra books also I have.
Okay. So with this outlook, start solving inverse trigonometric problems. Okay. Now I'll quickly explain. This is right now we did T inverse of T. Now this is T of T inverse X. All right. Now sine inverse X is equal to X. When does this happen? When X is between minus 1 and 1. Look at this composite function. The innermost function is sine inverse X, and that takes input of anything between minus 1 and 1. Sine inverse X. Okay, you can put input as between minus 1 and 1. And sine of anything gives an output between minus 1 and 1 only. Right? So only when X is between minus 1 and 1 will this be defined. So if I am to draw a graph here, okay, this is so that you guys get confused and then read it so closely that you won't get confused again. All right. If I draw a graph here, it's between minus 1 and 1. Both points are included, and this will be 1. Sorry, minus 1, and this will be 1 here. Not this. That's it. Input and output are coming like that only. All right. You can't put anything beyond that. That's the idea. The sine of sine inverse X will not be defined if you take any value beyond 1 and minus 1. Okay. Similarly, cos of cos inverse X. What will that be?
Minus 1 to 1.
It will be X for all X between minus 1 and 1. So if you're drawing cos inverse cos X and X graph, or sin inverse sin X and X graph, both have the same graph. Got this? All right. Any doubts here?
No, sir.
No, sir.
Okay. Now, let's draw sec inverse sec X equal to X. How does this work? Oh, sorry, that we drew before. Sec of sec inverse X equal to X. And that's what we're drawing now. How does this work?
All real numbers except minus 1 and 1.
Except those between minus 1 and 1. Okay. So,
Okay.
right. What you said is almost right. So, this is minus 1. This is 1. This is 1. This is minus 1. So, here to here. Is minus 1 and 1 included? Yes, it is. All right. this will be the graph. Okay. So x has to be greater than 1 or x has to be less than or equal to minus 1. Greater than or equal to 1 or less than or equal to minus 1. Same for cosec inverse x. Alright, equal to x. The same graph goes for both. Okay. Now, tan of tan inverse x will be what? Equal to x.
All real numbers.
Look, what we are basically doing is, in all of these terms, we are putting tan inverse x equal to theta. Okay, so we say that tan inverse x equal to theta means tan theta is equal to x. All right, so that's how we get x on the RHS. So here, what all values are accepted? All real values. So it's the entire line. Okay. All right. It's the entire line that's included. Same for cot inverse x. Okay, because all the values are possible for tan and cot. As simple as that. Okay, for sec and cosec, only values from 1 onwards, 1 and greater or minus 1 and lesser are included. Got this? Okay, this is C of t. And yeah, this graph is not that important as the first set, but I want you to know the difference between both. T inverse t is something else there, and T of t inverse is this simple equation here, simple set of graphs here. You can easily find this out. For this, you don't even need graph, frankly. All right. So we learn the properties. Okay. Sin inverse minus x will be what? Let's quickly go through the properties. I'll be there that we've discussed earlier today. We'll write them down neatly. Sin inverse of minus x will be what?
Minus sin inverse x.
Minus sin inverse x for all x between minus 1 and 1. Okay, this is the complete definition. All right. Next, cos inverse minus x will be
Pi minus cos inverse x.
Pi minus cos inverse x. Good, good, good. All right. For all x between minus 1 and 1. Okay. Next is tan inverse minus x will be
Minus
tan
tan
inverse minus tan inverse x for all x between
real numbers.
exactly any real number. This testing. Well done there. Cot inverse minus x will be, what is cot inverse minus x?
Pi minus cot inverse x.
Pi minus cot inverse x. Good, good, good. For like x, any real number. Now sec inverse cosec inverse. Sec inverse minus x will be pi minus sec inverse x for all. What is the value of x?
All real numbers except from 1 minus 1 to 1.
Nice. Except from minus 1 to 1. Basically, all numbers beyond 1 and all numbers beyond minus 1. Okay. Now, same for cosec inverse. All right, I'm not writing that separately. Cosec inverse minus x equal to minus of cosec inverse x, because you're looking at values between pi by 2 and minus pi by 2. Okay. But then here, x values will be similar. All right. Now, what else did we learn today? The next set of properties is sin inverse 1 by x is equal to cosec inverse x when
X is greater than 0.
Are you sure? No, no. Even when it's less than 0 also it is possible. But whenever 1 by x is between -1 and 1, or in other words, whenever x is in its domain of cosec inverse, as in x is between -infinity to -1 or 1 to infinity. Look, when I pass this value of x into sine inverse 1 by x, that 1 by x becomes between -1 and 1. Okay, so that is taken care of there. Did you understand what happened here?
Yes, sir.
Yes, sir.
Next. Any doubts? Any doubts? Please ask. Next, we have cos inverse 1 by x. That will be, what will that be?
Same. Sir.
Sec inverse x for x this way. Next, tan inverse 1 by x. This is what we learned properly today. These two are pretty obvious, but this is what we learned. What did we do? This became
Cot inverse x.
This became cot inverse x when x is positive, and when x is negative, what did it become?
Pi cot inverse x minus pi.
Exactly. Okay. Minus pi when x is negative. All right. Now, think of it. You can think of this differently in this manner. Okay. The quadrants, tan inverse 1 by x, you want to convert it to cot inverse. Tan inverse 1 by x is, if it is positive, cot inverse x should be positive and it will be managed directly in the first quadrant only. Okay. These lines and all will manage themselves on their own. Okay. Now, okay. So here, if you have tan inverse 1 by x as a negative value, it will be in the fourth quadrant between minus pi by 2 and 0. But when I say cot inverse x, cot inverse of that value, what will happen? You will get a corresponding second quadrant angle. Okay, that is between pi by 2 and pi. Okay, but we need an angle between minus pi by 2 and 0. So that is why from this cot inverse x that I'm supposed to get, I subtract pi units. I'm going in this direction, pi units. All right, are you following what is happening here?
Yes, sir.
Okay, so I subtract pi, that is where the minus pi is coming from there. All right, that should explain the minus pi. So you could have gotten cot inverse x, but that's not the case. You're getting a second quadrant angle there. I need a fourth quadrant angle, actually a -1th quadrant angle. Think like that. Okay, I need a lesser angle by pi units. So that's why I subtract pi there. Are you following? This is how it works. Did you guys understand this?
Yes, sir.
All right, this is pretty important. So learn that properly. I'll give you a few more conditions also. I know class time is over, but just hold on. We started pretty late. So sine inverse x plus cos inverse x is equal to
Pi by 2.
Okay. This will be pi by 2 for what all values of x?
-1 to 1.
-1 to 1. Correct. You're just checking the domain, guys. You should automatically start checking domain when you get functions like this. Okay. Now tan inverse x plus cot inverse x equal to pi by 2 when x is between?
All real numbers.
Okay. Also remember sec inverse x plus cosec inverse x will also be equal to pi by 2 for x between r minus -1 to 1. Those are the values sec inverse x, cosec inverse x can absorb. Okay, for x. So remember these properties as well. Then what do we have? Okay. Next class we'll do multiple angles. Okay, multiple values together, adding and subtracting. And by that, the chapter should get over. And then I think we should practice more problems. So we'll spend one extra class on that. Okay. That'll be next class. So we'll combine angles together, practice tough problems, and get you ready for JEE Mains. After which we'll start calculus. Okay.
Okay, sir.
I thought I'll finish this today, but we'll do it next class properly. Okay. Done. So guys, just try to learn the formulas that are there and come with doubts, please. Can you do that much?
Yes, sir.
I told you what the upcoming formulas are. Like you're combining tan inverse x plus tan inverse y, like stuff like that. Okay. So come with doubts for that. And yeah, I'll see you next class. Right.
Thank you, sir.
Thank you, sir.
Thank you. If you have any doubts, please ask.